You can start whenever you're happy to go. You can click on record and then just start teaching.
Hello, everybody. Let me welcome everyone to our first grade 12 technical mathematics. My name is Mr. Posa from Africa Jigs. As you can see on the screen, today we'll be dealing with trigonometry under paper 2. Now, before we can go on, I just want to explain that this topic, it forms paper 2, it forms part of paper 2, and it's one of the topics that contributes a lot of marks. So learners, if you deal with trigonometry, make sure that you practice everything under trigonometry because it's very important and it contains a lot of marks for paper 2. Now, we are now working towards the trial examination, and it's very important if you can start now with revising your work as now, because you'll find that majority, if not all schools that are offering technical mathematics, they are done with their syllabus. So it is advisable to start with the revision as now, because by the time we are going to write our trial examination, you are going to have more subject that also need attention. So it's very important to start as early as now, so that you prepare yourself thoroughly. Now let's move on and see what we have under trigonometry. All right, thank you very much. Under content, then I've tried to break this topic of trigonometry that shows the subtopic that falls under trigonometry. But before that, I just want to show you something, that this topic of trigonometry is worth 50 plus or minus 3 marks for paper 2. So you can see that this topic really is very important. So, but today we are going to make sure that we understand all the concept that we as learners that we need to revise thoroughly. So now under trigonometry, the first subtopic that falls under trigonometry is trig ratios, identities, and equations. Then we move to trig functions, and the last one is 2D and 3D problems. But you can remember that the first one, which is trig ratios, identities, equations, together with trig functions, and the last one is 2D. It's just a revision to us. We have done them in grade 11, if you remember. The only thing which is new to us here in grade 12 is 3D problems, which is 3-dimension problem, right? So, but it's very important if we recall what we have done in grade 11, because it's going to form part of that trigonometry, and which is going to be on our paper 2 for trial examination, and as well as the final examination. But today, our focus is going to be only on this topic, which is 2D and 3D problems, the one that we were busy with it in grade 12. And then the other subtopic, they are going to be done on the next lesson, right? Now, let's move on and see what we have under 2D and 3D problems. Now the introduction, like I said, that we have 2D and 3D problems. Then we are going to deal with 2D problems as well as 3D problems for today's lesson. Now, when dealing with 2D and 3D problems, then one should remember on how to apply the sine rule, the cosine rule, and the area rule. And you must be able also to solve the problem in 2D dimension using the sine rule, the cos rule, and the area rule. And then it's very important if one can be able to apply the sine rule, the cosine rule, and the area rule in 2D and 3D dimension. But remember, for us, it's not a new thing. You remember you did this, learners, in grade 11, where you were given a 2-dimension problem, and we're applying what? The sine rule. We also apply the cosine rule and the area rule. So you're solving any problem that needs you to apply the sine rule and the cosine rule, and the last, the area rule. So we are going to talk about that. And now in grade 12, since we have introduced what the 3D dimension problem, we're still going to apply those sine rule and cos rule and the area rule, right? Then let's see what we have. Now, let us look at these two main types of triangles. The first one we're going to look at is a right-angled triangle. And the second one is non-right-angled triangle. Now, here we have one picture of a right-angled triangle, and the other picture is non-right-angled triangle. So these are the two triangles that we're going to deal with, right? These are the two triangles that we are going to focus on today. Now, it says when right-angled triangle is given, the following should be used. For instance, if let's say you are given a right-angled triangle, and then you have to calculate a side, or you have to calculate an angle, then the following should be used in order to solve any side or angle specifically for right-angled triangle, right? We have Pythagoras theorem. Now, if you remember very well, for us to use this theorem, Pythagoras theorem is, for instance, if let's say we have two sides, you are given two sides on a right-angled triangle, then we have to calculate the third side. Then you can now use what? Theorem of Pythagoras, right? And then we move to trigonometry ratios. You can see on the left-hand side of this right-angled triangle, we have example of those trig ratios, which is sine theta equals to y over r, and then we have cos theta equals to x over r. The last one is tan theta equals to y over x. Then we also use those to calculate sides, or we calculate the angle. Now, when we have non-right-angled triangle, and we have to calculate the unknown sides or the unknown angle, now what to use? Now, in this case, we are using the sine rule, the cosine rule, the area rule. Let me repeat: the sine rule, the cosine rule, and the area rule. If the angle is given, and this angle, the triangle is given, and this triangle is not right angle triangle, and then we have to calculate, for instance, a side. So you are now going to use, it's either going to use the sine rule or the cosine rule to calculate that side. Or for instance, if you don't have a what angle and you are asked to calculate that particular angle, then we're going to use the sine rule or the cosine rule. And the last one, you have to calculate the area of that particular triangle. Now, let's have now non-right angle triangle. All right, now, the question, or someone should understand that when we use sine rule, there are conditions that we need to know, or we need to remember. One of the conditions for us to be able to use the sine rule, the fact it says, given two sides and one angle that is not between the two given sides. For instance, if you are giving a triangle, and then in that triangle, you are given two sides, one angle that is between the two given sides, then in that case, you are going to use the sine rule to calculate whatever you are being asked to calculate, whether it's a side or the angle. But as long as that triangle, it has two sides and one angle that is not between the two given sides. Now, another condition for us to use the sine rule is when we are given two angles and a side. So if you come across a triangle that have two angles and one side, then in that case, we also going to use the sine rule to calculate a side or an angle, right? Now, when to use the cosine rule? When to use the cosine rule? There are also, we also have the condition under that. The first condition is when we are having all three sides. Here's the triangle. And then in that triangle, we are being given three sides. Then in that case, we are going to calculate using what? The cosine rule. Another condition for cosine rule is when we are given two sides, one angle that is between the two given sides. Listen to this: given two sides, one angle that is between the two given sides. So please remember, don't confuse this one of sine rule, where you are given two sides and one angle that is not between the two given sides. Now, this one of cosine, it says you are now given two sides and one angle that is between what? This given side. So in that case, then we are going to use the sine rule to calculate. All right. Now, the last one is when we have to use the area rule. When to use the area rule? If, for instance, you're being asked to calculate the area of any triangle, then you must meet the following condition before you can be able to calculate that area. Given two sides and one angle that is between the two given sides. Now, for you to be able to use the area rule or to calculate area, that triangle should have what? 2 sides and 1 angle that is between the 2 given sides. Then in that way, you'll be able to calculate the area of that particular triangle. All right. Now let us have example on non-right angle triangle, but specifically for 2D, 2-dimension problem. All right. Now the example that we're having here, on the left-hand side there is a formula for sine rule. So this is going to be the formula for sine rule, right? So now in the formula sheet, they will sometimes write it in this form, or it will be written in this form. So either way, you can use the first one or this one, the second one, it's no problem, right? Then as you can see, this small letter A represent the side, this side here. So it's A divided by sine angle A, right? So this is the angle A, and the opposite side of this angle is going to small letter A. Then we have small letter B divided by sine angle B, which is this one, where we have this angle B, and then a side which is opposite to this angle, which is going to be small letter B. Then the same applies with this angle C. This side is going to be small c. So this is the formula that we are using to calculate any triangle where we have to apply what? The sine rule, right? Now let's see if we can have one example. Now in this case, it says use the information in triangle ABC to find the length of AC, then round off your answer to 1 decimal place. Then we have example. This is the triangle that we are having. Now before we can calculate that length AC, we first have to check what we have. Because remember, there are two things, it's the sine rule and the cos rule. So we don't know which one to use. So we are going to check what we have, and then we'll then decide which one we are going to take. Now in this case, we are having two angles. Can you see that? We are having two angles, which is angle A, which is 46 degrees, angle B, which is 58 degrees, and one side of BC, which is 6 centimeters. Now, if you remember very well, when we were dealing or reading the conditions of both sine rule or the cosine rule, and then which condition that speaks about having two having two angles and one side. That condition, I think it was under sine rule. Now, meaning for us to be able to calculate this side of AC, then we are going to use what? We are going to use sine rule. Now let's see if we can do that. Our solution, let's see how to calculate that side AC using what? Using the sine rule. Now the first step, you have to write angle and a side which are given. For instance, if we can look at this diagram or the triangle, we have angle A And we also have what? The side. A side opposite to this angle is also given, which is 6 centimeter. Then it means we're going to have A, which is small letter A, divided by sine angle A, equals to this angle B, which is 58, and then side, which is opposite to this angle, is the side that we are in need of, which is AC, right? Then remember, I cannot include what? This angle C together with the side, which is AB. Because remember, our question, it says we should calculate or find the length of what? AC. All right. Then let's see what we have thereafter. Then we all know that A is 6 centimeter divided by sine angle is 46 degrees equals to small letter B. We are going to substitute with AC is what we in need of, divided by sine 58 degrees, right? Now, in order for you to calculate that AC, in this case, we are going to cross multiply because we want to make AC the subject of the formula. Now, after we have cross multiplied, then this is the answer for the side AC, the side AC. So our answer is what? 7,07 centimeter. But because we were supposed to follow the instruction that says round off your answer to 1 decimal place, so the answer was supposed to be 7,1 centimeter. So please, learners, every time when you receive a question paper, so don't rush to go and answer the question. Read your instruction very carefully, especially this instruction of how many numbers you should write after comma, you see. So you must make sure that you follow that instruction. So if you say 2 decimal place, you must write 2 numbers behind the comma, right? Thank you very much. Now let's proceed. We still have another example under non-right angle triangle for 2D. Let's see. All right. Now we have a triangle next to it. These are formula for the standard formula for calculating using the cosine rule. The first one, if you can see, it says A squared equals to B squared plus C squared minus 2BC cos angle A, right? The other one is B squared equals to A squared plus C squared minus 2AC cos angle B. And the last one is C squared equals to A squared plus B squared minus 2AB cos angle C. Now, for instance, if let's say we were supposed to calculate this angle A here, or the side opposite to this angle, then whenever we have to write this formula, we are going to start with this one of A squared, right? Or if let's say we we have to calculate this angle B here, or the side opposite to this angle B, which is this one. Then we'll have to start with this. We are going to start with a small letter B, then you square it, equals to the other two sides, right? Now, let us have example where we are going to apply or use the cos rule. All right, it says, in the following triangle, calculate the length of AC. Write your answer with 2 decimal places. Let's see the triangle. This is our triangle. Now, before you can think of which one to use, you first have to check what do we have. What do we have? Because we have to choose between the sine rule or the cosine rule, which one, right? Now let us see the condition that will be on this triangle. Now in this triangle, we have the side AD and the side DC. Sorry. All right. We have 2 sides and 1 angle. And then when you look at to that angle, is between the 2 given sides. So we are having 2 sides and 1 angle, which is between the 2 given sides. Now, if you remember, this is the condition for what? The cosine rule. So meaning in this case, we are going to calculate side AC using what? Using the cosine rule. Now let us see on how to go about it, how to calculate that side using the cosine rule. Sorry, the cosine rule. Now, like I've said, now it's a pity. Let me just check here. Now in this case, actually here, it's a typing error. So it was supposed to be angle B, and then opposite side of this angle supposed to be small letter b, right? Then remember I said if that is the case, we have to calculate the angle or the side of this small letter b. We are going to start with it when we have to write our formula. So our formula is going to be b squared equals to a squared plus c squared minus 2ac cos angle b. Remember, I said this angle D is just a typing error. That's supposed to be B, right? Supposed to be B because look at here, we have A, you can't have D and C, right? So it's supposed to be A, B, C. Now the next step, we are going to substitute. Now our value of A equals to 14. Then whenever I see A, then I'm going to put that 14 there. And then the value of that side of C is 12. Wherever I see C, and then I'm going to substitute what? With 12 and so forth. Then after we have substituted the values, then you can just press your calculator. Let me just have my pen here. All right. Now, when you reach this stage here, you can just use your calculator, put everything in your calculator and equal sign. Thereafter, you're going to obtain what? This value here. And make sure after you have obtained this value here, please, learners, don't round off your answer. You only round off our answer at the end of everything else, right? You write everything, all those numbers that you see on your calculator after you have you have put everything in your calculator. You write them all, right? Thereafter, at the final answer, that's where you're going to start to write your answer with 2 decimal, right? Then you are going to what? You square both sides. Remember, we are in need of what? We are in need of B. We are in need of B. So we had to get rid of this 2 here, this exponent 2. So if that is the case, then we have to square both sides so that we can have the value of what? B. Then our value of B equals to what? 8,05 units. So we have just calculated what? Side AC. We have calculated side AC, which is 8,05 units. So we used cosine rule. Why? Because we were having 2 sides, 1 angle, and this angle, it was between these 2 given sides. All right. Let's proceed. We still have example on non-right angle triangle on 2D. Right. Now in this one, as you can see on the screen, we are going to be dealing with the area now. We are going to be dealing with the area. Now, I hope you still remember the condition for us to be able to calculate what? The area. Remember, the condition says you should have 2 sides and 1 angle that is between those 2 given sides. Then if that is the case, you'll be able to calculate the area, right? All right, let us study the first formula, which is this one. You say area equals to half times BC sine angle A. You can see we have small letter B, small letter C. Let's see. All right, for instance, if let's say we are given this angle here, A, and we are given what? Side, this side C, and we're also given the side B, then this is the standard formula for the area that you're going to use, right? I hope you understand. Meaning you'll be having this side of side C, you'll be having what? Also this side B and this angle, right? So in that case, we are having 2 sides and 1 angle, and this angle you can see is between those 2 sides, right? And then let's move to the next one, which is this one, where it says area equals to 1/2 small letter A, small letter C, sine angle B. Now in this case, if we have to use this one, surely you must have what? Angle here, and what? You must have this side A, you must also have the side C, right? Then you will have 2 sides and 1 angle here at angle B here. You must have angle and this side where you see small letter A, and this side where you see small letter C. Then you're going to use this one to calculate the area. All right. Let me just raise this one. All right. Now let's move to the next, which is the last one. This one, area equals to 1/2 AB sine angle C. You can see it says small letter A, small letter B, sine angle C. In this case, you will be having this angle C here. You must also have this side A. You must also have this side B. Now you can see you'll be having two sides, right? So this side of small letter A, this side of small letter B, together with this angle. And this angle is now between what? These two given sides. Then that's where we're going to be able to calculate what? The area. We'll be calculating the area. All right. I hope you can see that. All right. Now let's proceed. Hopefully we'll get question where we will have to calculate the area. All right, it says in the following triangle, calculate the area. Run off your answer to do decimal place. Let's see. Oh, we still have that triangle that we calculate using the cosine rule from the previous slide. All right, now in this one, we have to calculate the area. Now, before we can start, we have to study our triangle. We have to study our triangle to check whether this triangle has two sides and one angle which is between the two given sides. Remember, that is the condition for us to, for you to be able to calculate what? The area. Now, in this case, we have what? Side C, which is 12. And then this side also is what? Is 14. And then we have angle here. We have angle here. We have side there. And then we also have side here. So now, if that is the case, then we'll be able to calculate the area for this triangle. Now let's see, how do we calculate it? You first have to write your standard formula for the area, because we know the value of small letter A, the value of small letter C, and this is going to be the standard formula that we have to write. Then after writing this, then you're going to now substitute your values. And then we have 14 here, we have 12 there, sine what? 35. That is the angle that we are having. Thereafter, you just press calculator. Then you will have your value there, which is 48,18 units squared. Please, my dear learners, when you are calculating the area, your answer should have squared. For instance, if let's say we have units of centimeter or meter, so if it's centimeter, it's going to be centimeter squared. If it's meter, it's going to be meter squared. In this case, we don't have any units, but that is not the problem. We are going to use what? Units squared to show that you were calculating what? The area. Because if it does not have a squared, we will never know whether you are calculating area or what. So the only way to know that you are calculating the area, then we are going to see it with this exponent 2. So our answer in this one is 48,18 unit squared. So this is how you calculate the area. The area. All right. Thank you very much. Let's proceed and see what we have. Now, we still have example, but We have example for non-right angle triangle in 3D. Remember previous problems, we've been dealing with what? With 2D only. We have calculated sine rule. I mean the sides or the angle using the sine rule. We also calculate the side and the angle using the cosine rule. We also calculate what? The area. So it was under what? 2D. Now in this case, we are now having what? 3D. The one that it was introduced to us in grade 12. Right? Now let's see what we'll have under 3D. Oh, we are having a question for 3D. Now remember, 2D and 3D, they are the same. It's just that in 3D, it's a combination of more than two triangles combined together to form 3D. So the way we're calculating the side using the sine rule, the way we were calculating the angle using the cosine rule, we are going to apply the same way. We're going to calculate it. So there's nothing new for 3D that we have to learn. So we're still going to use our sine rule, the cos rule, the area rule if it has been asked to calculate, right? Now let us read what we have and then see if we can be able to understand the 3D. A, B, and L are points in the same horizontal plane. This is our A, and then we have B and what? L are points in the same horizontal plane. HL, this is the HL, is a vertical pole of length 3 meters. Then AL, where is our AL? This one, this is our A, this is our L, is equals to 5.2 meter. And then A angle LB equals to 113 degrees, which is this angle here. This angle here is 113 degrees. In the angle of elevation of H from B is 40 degrees, meaning they are referring to this angle here. That angle is what? Is 40 degrees. So the first question that you might get is you have to calculate the length of what? Of LB, the length of LB. Now, before we can calculate that length of LB, now you can see we have more than one triangles in this picture. We have HLB, we have HLA, we have ALB, and the last one is ABH. You understand? So we have 4 triangles. Now, if the question comes say that we have to calculate the length of LB, we check where's LB. This is the LB. Is this one here? We have to calculate LB. Where's is this one? Sorry, let me erase this one. Let me erase this one. All right. Now let's go to LB. This is the LB. So we are in need of this side, LB. We have to calculate that side. And then when you check LB, it's part of what? Of this triangle HLB and ABL. So that side is part of those two triangle, right? Now, we are going to calculate it, and then let's see on how to calculate that. Number one, we are having tan angle B equals to what? HL over LB. Let's go and see why they've used tan. Now, if you can check on this triangle, HLB is right angle triangle. If you remember what we talked about under right angle triangle, we are going to use what? We are going to use trig ratios to calculate any side, to calculate angle. Now, in this case, you can see that we are having that right angle triangle there, which is HLB. That is a right angle because we have 90 degrees there. Can you see it? There is 90 degrees there. So we are going to use what? Trig ratio. Now, you have to choose which one is going to be the one that we're going to use. Remember, we are having sine theta equals to opposite over hypotenuse. We have cos theta equals to what? Adjacent of hypotenuse. You've got what? Tan theta equals to opposite over adjacent. Now, since we're having this angle here at B here, then the side which is opposite to this angle, which is HL, is our opposite, right? Then, if that is the case, this length LB is going to be our adjacent. Now, we now know that tan theta is equals to opposite over adjacent. Hence, we have used what? The tan to calculate that side LB. I hope you do understand. Let me just remove this and see. Let me just remove this one. All right. Thank you very much. Now let's proceed and see what we'll have. The next step, you then substitute your value. Then we are going to have tan 40 degrees equals to 3. Remember, this 3 is what? Is this opposite side, HL, 3 meter, divided by what? LB, the one that we are in need of, LB. So remember, we are calculating that side of LB. So we used the trig ratio of tan. Then from there, you are going to do cross multiply. Then after you did your cross multiply, then the value of LB or that side is 3,6 meter. The length of LB is what? 3,6 meter. Right. Second question, hence or otherwise, calculate the length of AB. Let us go and see where is our AB. This is our AB. So we have to calculate this side. Now, when you look at that side, it's part of this triangle ABL, right? ABL. And we've just calculated the length of LB, which is 3.6 meter. Now let's see. Oh, they are now using what? They are using the cos rule. Why are they using the cos rule? Let us go and see why they have used the cosine rule. Now look at here. We have the length LA, which is 5.2 meter. We also have what? The angle here at L. We have that angle. Then we have the side LB. So in that case, we are having what? 2 sides and 1 angle. And when you look at that angle, it is formed between these 2 given sides. hence we are now using what? The cosine rule, right? I hope you understand. Let me just remove this, and then the next step. Now, since we are looking for this side of AB, then surely this side is going to be small letter L, right? Then we're going to substitute everything. Then after we have substituted, then you just press your calculator. Remember, like I've said in the previous example, you can just press your calculator, take every number there, the way as it is, then you put it in your calculator, then equal sign, then you write all those numbers that you see on the screen of a calculator. Don't round off. We only round off your answers, your values when you reach the final step. So in this case, remember we're still in need of L, so it still have L squared. So we're going to square both sides to calculate that side of AB. Yeah, it's AB. All right, so after we squared both sides, then our side is 7.4 meter. So we've just calculated what? That side AB. So this side AB is 7.4 meter. Right. The last question. It says calculate the area of triangle ABL. Let's go to triangle ABL. AB is this one, and then L, meaning is this triangle here. So we are going to calculate the area of this triangle here. I just want to show you which triangles we are going to calculate. Let me just remove this one. All right. Then from L to A here. Right. Then from A to B, this is the triangle that we are going to calculate the area. Now, let's see this next step. The area equals to half times AB sine angle L. Now, if you still remember the condition, we must have two sides and one angle. Remember, we have just calculated what? The side LB. We have calculated side LB. And then if that is the case, then we'll have two sides and one angle. And this angle you can see is between those two sides. Then we will be able to calculate the area. Now we just substitute. After you have substituted your values, our area is going to be equal to 8.6 meter squared. 8.6 meter squared. Please, learners, don't forget to write that unit, which is meter squared. Okay? So if it does not have units, you write unit squared to show that you are calculating area. Yeah, that is that. I think we are done with our question under 3D. We are now having the activity based on 3D and 2D. You can just take this question and then test yourself as to whether you can be able to apply sine rule, cos rule, and the area rule. my dear learners, this is the message for you for today. That says study like there is no tomorrow, because if you keep putting off your studies for tomorrow, then you will probably be late. So let us make sure that when we get time, when we get chance, we practice as soon as possible, because we are close to write our trial examination. Thank you very much.